In this video, we'll take a quick tour of the AMI DCM console and check out some of its key and latest features. In a previous video, we showed you how to install DCM on Windows or Linux and how to add devices to start monitoring them. Assuming you've already done that, the next step is to log on to the DCM console with the credentials you created during the installation process. Once you log on, you'll see the main dashboard, which is designed to give you a holistic overview of your environment using customizable gadgets. The dashboard consists of gadgets that give you an overview of the environment, including things like the number of rooms and racks, as well as the total number of devices being monitored. There are also capacity-related gadgets that show you the total power consumption, the used and available power and space and weight capacities. You also see some sustainability-related gadgets that show you your annual carbon emissions, your carbon usage effectiveness, the percentage of renewable energy, as well as your annual and monthly actual and projected carbon emission trends. There will also be some important device statistics that show you how many devices were powered off, deemed unhealthy, or have lost connectivity. There are also some temperature-related gadgets that can indicate the highest temperature any device has reached, as well as the hottest 3 rooms in your environment. Moving down, we can see the most power-consuming devices as well as the hottest devices in your environment. You can also see the aggregated power and temperature graphs for all devices over a period of time. Here we've chosen a week, but you can change that to be anything from an hour all the way up to a year. There are also several gadgets that give you details about the different events that you've subscribed to from the settings, including things like power failures, connectivity interruptions, overheating, and more. DCM can also detect cooling anomalies such as sudden or unexpected changes in temperatures of devices in a certain room that may indicate room-level cooling issues. And finally, DCM can detect firmware outliers, where the firmware version of a component of a specific device model can vary significantly between devices. Let's say we want to take a closer look at the devices that are consuming the most power. Clicking on the server will take you to the hierarchy page and will show you the details of this particular device, including its inventory information, its current health status, the status of its subcomponents, its fault history, its sensor readings, as well as its temperature, power, utilization, and carbon emission details over a period of time. You'll also see any events that you've subscribed to and statistics about these different events. It's clear that this system is being highly utilized as indicated by the CPU utilization, memory bandwidth, and I/O utilization, which is probably why the power consumption and the carbon emissions of this server are quite high. But it's worth noting that this system has health issues that have been going on for a while now. So as a next step, it might be worth downloading the SEL logs and checking them out in more detail to find out what might be the problem, and maybe also clicking to access the remote management console to see what's going on the server itself. All of this information is retrieved out of band using protocols like IPMI and Redfish, which is one of the key features of DCM, allowing you to get such granular level detail without the need to install anything on the system that may impact its performance. Another key feature of AMI DCM is its ability to perform server firmware updates for servers that support firmware updates using Redfish, like this server, for example. If I click on the provisioning tab, I'll be able to locate a server firmware file for this model and allow DCM to perform that update. And I can run that firmware update either now or at a specific time to minimize downtime. You can also perform server firmware updates for multiple servers of the same model if you go to the Devices tab and select several servers. Another firmware-related feature is DCM's ability to show a distribution of the firmware versions for different components of servers of the same model. So for this server as an example, most other servers of the same model are running the same management module firmware version, but others are running significantly older versions. This kind of information may allow you to make firmware update decisions accordingly, since it may impact reliability, performance, and security. You can also see this same kind of information for other server components, such as the BIOS, drives, and so on. One of DCM's strengths is its ability to aggregate data as you move up the physical hierarchy. While we were seeing the power, thermal, and carbon emission details and events for this particular device, we can see that same type of data on the rack, row, room, and data center levels accordingly. You can also click on the Devices tab and then click on Groups, create logical groups of devices regardless of where they exist in the physical hierarchy. For example, I've created here a few groups of servers running specific workloads, and this can allow DCM to calculate the power, carbon emissions, and temperature details even on a workload level. Clicking on the Sustainability tab on the left here takes us to a more detailed view that shows us the carbon emissions relative to any set thresholds. So in this case, we see that while we're still good on this month's carbon emissions, it seems like we might exceed the annual set threshold if we follow this line by maybe the month of October. DCM takes note of that and can send you alerts as you get closer to that threshold. A first quick and easy preemptive measure we could take is click on this tab over here to see which servers in our environment are underutilized and therefore unnecessarily consuming power and space. And you can see how much carbon emissions can be reduced by consolidating or taking down such servers. Another action we can take is click on the Sustainability tab and look at the cooling analysis to see if we are unnecessarily overcooling some of the rooms in our data centers. If most of the servers in a room are running cold, it might be a good opportunity to safely increase the set point temperature to reduce the energy spent on cooling. This is not really the case in this room in particular, but it was very easy for us to verify that. We can also click on the Server Characteristics tab to see the power characteristics of all of the different server models that we have. We can also click on Server Replacement Analysis to see the impact of removing, adding, or replacing servers on your carbon emissions. For example, if I need to add a certain number of servers of this particular model starting June, and let's say I need to add 50 of those, once I click on Analyze, it will show me the impact that would have on my total energy consumption as well as my carbon emissions. So you can see here that my energy consumption will increase by around 40 megawatt hours in the next 3 months, and my carbon emissions will increase by around 23 tons in the next 3 months. And this is based on the historical average power consumption of this particular server model in my environment. Now let's say that these 50 new servers are meant to replace 50 older servers starting June. And you can see here that these are older servers that are probably less capable from a compute perspective, but they're also way more power hungry. This is based on the historical average power consumption of this particular model in my environment. Once we click on Analyze, we will see that while I'm increasing my compute power, I'm also reducing my carbon emissions. And this could be a very powerful tool in driving data center efficiency and sustainability.